Hello, I'm Ruiz Aguirre, and I'm going to discuss the functional group of ketones, how to name, draw, and a sample of it in nature.
Ketones is an organic compound that is simply and lacks of reactive group. It is a carbon with a double-banded oxygen. We need to know that the name of ketones, they all end in -one. Here we have 1, 2, 3, 4, 5 carbon chain, which is pentan. All are carbon-carbon single bonds. So we have to put 2 to show that's where the ketone is. The name will be pentan 2O. In this structure, we have 8 carbon chain, and I number it so that the double-banded oxygen gets the lowest number because it is the highest precedence here, so we have an oc and a double band starting at the carbon 5, and we have to add n, so we have the double-banded oxygen, which is 2O, so the name will be oc5n2O. In this structure, we have to get the lowest number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a non. All the carbons are single band, so it's a nonan. And on is on the carbon 4. So the thing is, we have hydroxy on carbon 8 and then an ethyl, a 2 carbon chain hanging on the carbon 7. So this becomes 7 ethyl 8 hydroxy. So the final name will be 7-ethyl hydroxynonan 4-on. Ketones are widespread in nature. The example of these are the pheromones. Pheromones are chemical released by an organism into its environment, enabling it to communicate with other members of its own species. They are released by both insects and mammals in many situations, such as finding food and mates, and aggregating to take advantage of food resources. Ketones also can be found in the field of medicine. The drug cortisone is a ketone used to treat severe allergies, arthritis, asthma, multiple sclerosis, and skin conditions.
Good day everyone, my name is Tiffany Jane D. Regusta, and I am going to tackle about the amides. 3,4-dimethyl hexanamide. To draw this structure, we start with the parent chain of the structure, which has 6 carbons, the name hex. After the parent chain, we draw the amides group at the start of parent chain and draw the methyl substituents. There we have it, 3,4-dimethyl hexanamide. Next, we have 3-methyl butanamide. To draw this, we start again with the parent chain, which have a 4 carbon chain from the name but. After the parent chain, we draw the substituent methyl to the 3rd carbon and the amide group to the start of parent chain. Next, we have ethanamide. To draw this, we start with the parent chain and draw the amides group to the 1st carbon of parent chain. There we have it, the ethanamide. Amides are commonly found in nature, and they are the building blocks of proteins and peptides. Amides represent the group of organic compounds associated with ammonia. Amides contain a special kind of linkage known as an amide linkage. The bond of an amide is an amine condensed with an organic acid. Here are the 2 examples of amides. The first one is caffeine. Caffeine is a stimulant found especially in coffee. The effective dose of caffeine is about 200 milligrams, corresponding to about 2 cups of strong coffee or tea. The second one, basically the last one, is the acrylamide. It is used in different applications, but is best known as probably carcinogenic and be present in many foods such as breads and fries to be formed by natural processes to cooking.
Hi everyone, I am Guarino, and now it is my turn to discuss to you about esters. I'm going to show you some examples of its structures and where it is found naturally.
Okay guys, so here we have 3 examples. First one is the ethyl butanoate. To draw this, we draw the parent chain which have 4 carbons from the name but and draw the ester group to the carbon 1 and draw the ethyl substituent attached to the oxygen from the ester group. Next one, we have the pentyl octanoate. To draw this, we start with the parent chain again, which have 8 carbon from the name oct, and draw the ester group to the first carbon of the parent chain. Lastly, we have the methyl 4-bromoheptanoate. To draw this, we start with the parent chain which have 7 carbon. Next, we draw the ester group to the first carbon and draw the methyl attached to the oxygen from the ester group. Then lastly, we draw the bromide into the 4th carbon from the parent chain. That was all, guys. Esters are steadily synthesized and naturally abundant, contributing to the flavors and aromas of many fruits and flowers. For example, the fruity aroma of pineapples, pears, and strawberries are caused by esters, as well as the sweet aroma of rum. The ester methyl salicylate is also known as the oil of wintergreen.